We're going to look at spheres a little bit more in depth, and we're going to kind of build off of what we did with cones, and we're going to work on finding a missing measurement given the volume of a sphere. So, because we're dealing with a sphere, we need our sphere formula for volume as well. So the volume of a sphere is 4 times pi r cubed divided by 3. All right, so just like we did before, we start with our formula, plug in the information that we know. So volume, V, is 33.49. I'm going to keep 4. I'm going to keep 3.14. I'm going to keep r cubed, and I'm going to divide by 3. Well, we can now get rid of this divided by 3. So times by 3 times by 3. So 33.49 times 3, that's going to give me 100.47. This went away, so now I'm left with 4 times 3.14 times r cubed. Times r cubed. I'm going to zoom this in a little bit. There we go. All right. This is just a number. Let's find out what that number is. So 4 times 3.14 is 12.56. Still have my r cubed. Divide by 12.56. And I end up with 100.47 divided by 12.56. Ooh, it's 7.999203822. Now, because we used pi, it's 7.99920, so on. We're going to just make that 8. We're going to round that to 8. And the reason you'll see in a second. 8 equals r cubed. So because we rounded our pi at 3.14, our number is just a tad off than what it in reality would be with a pi symbol and that actual full pi number. So the reason we make it 8 is I can kind of think about this now. What times itself 3 times makes 8? Or what's the cube root of 8? And that would be 2. Because 2 times 2 times 2 makes 8. So the radius of that sphere is 2. All right. We're going to look at another sphere problem, but this time they tell us something a little goofy. All right, so here it is. A sphere has a volume of 8 pi inches cubed. What is the radius of the sphere? 8 pi. Well, they just give it to us in an exact form. So this is called exact form. So what we just have to do is we have 2 options. We can multiply that out. So 8 times 3.14 and say, you know what? Let's just make it 25.12. Or we could, actually, we'll just do that. We'll multiply it out and we'll use that for volume. So that is V. All right, so let's start with our formula for volume of a sphere. So volume equals 4 pi r cubed. No H. Ooh, I caught myself. No H. Very common, though. You might do that by accident, so be careful. 4 pi r cubed. Now, I did remember the cube, which is good, divided by 3. I'm going to put in my new V, 25.12 equals 4 times 3.14 times r cubed divided by 3. Now, hopefully you've watched this far, because I'm going to show you a trick we can do to kind of shorten this process. We can actually do all of this and simplify it. We can do all of that and simplify it. So in the last problem, we did it in 2 steps. Here, we're going to do it in 1 step. So I'm going to take my calculator, and we're going to do 4 times 3.14. 4 times 3.14, and divide that by 3. Gives us 4.186. And let's just round that to 4.19. R cubed equals 25.12. Now I just have to divide by 4.19. Now remember, you know how we rounded that? It was 4.186666. If we round it to 4.19, we actually get an answer of 5.9952 and so on equals R cubed. Not a huge fan of that, so what we're going to do is we're going to say 6. We're going to round it ourselves, R cubed. Now, this isn't nice. I can't think of a whole number that multiplied by itself 3 times makes 6. So what we have to do is we have to use what's called a cube root. Here's how that works. Mine's a little trickier. What you're looking for, I'm going to show it to you where you would find it on your calculator. You're essentially looking for this. It's going to be a square root symbol or a radical symbol with an X there. And what you're going to do is you're going to hit 3 and then hit that symbol and put your number 6. So I'll show you kind of how I would do it on this one. I don't have the same calculator as you, unfortunately. I hit 3 like you would. Then I have to find that symbol. That symbol is here for me. And then I'm going to put in a 6. So my answer is 1.817. And that is how we would find the radius of a sphere given the volume. Hope this helps. It kind of takes what we did with cones and takes it one step further with spheres and that cubed idea.